Hello friends, we are once again meeting. In the intro session, we start with the question, why we need surveying, right? And what is surveying? Without surveying, can we do anything? That's the ultimate question here. I have said about the surveying is of measurement and the fixing of direction. Without fixing direction and without doing measurement, what will happen? So that's the point. We need what is surveying and how we can define surveying. So already I have explained about the course outcomes. 5 outcomes are there. In that first one is to calculate the areas and include an angle based on the concept of chain, compass and plane table surveying, that we are going to concentrate now. Apart from that, the overall general objective of this surveying course is to understand the basic concept of surveying, apply the surveying concept and equipments in real life. That is more important. I need to use it in my real life. You should be able to use a set of tools to solve the problems in an optimal way. You should be able to understand the pitfalls, that is source of error, and how we can avoid it. That is the general objective of this course. The first course outcome, in that learning outcome 1 is explain the principles and types of surveying. Even this can be divided into specific outcomes. 5 specific outcomes we have split it. First is the define surveying with respect to the relative portion. Second one is list principles of surveying. Explain the importance of working from whole to part in surveying. List the types of surveying. Compare the types of surveying. So the first question, if you are moving to the new place and from your friend or from your home, somebody is calling you and they are asking you, where are you? What will be your answer? I am here is the right answer. Then they will ask, where are you? Then can you say, I am here, this lat long, 75 degree, 25 minutes north, 10 degree, 11 minutes, 5 seconds south. Is it possible to understand by them? Then how you will answer? Again they will ask the same question, where are you? Then you have to say, I am also new to here. Then they may ask, any nearby landmarks. What is that landmarks? Then you can look around, you can see, I am standing in the bus stand, I am standing nearby a post office, I am standing nearby a theatre. These are the things, the common landmarks. You can try to relate them so that they can understand, oh, you are nearby that. So this landmarks or the reference is called the relative position, right? So define surveying with respect to the relative position is the first specific outcome of this. Based on B.C. Punmaya, surveying is the art of determining the relative position of points on, above or beneath the surface of the earth by means of direct or indirect measurement of distance, direction and elevation. It also includes the art of establishing points by predetermining angular and linear measurement. It involves both the angular and linear measurement. The application of surveying requires skill as well as the knowledge of mathematics, physics and to some extent of astronomy, right? By Dougal, one more author of surveying, it is defined as an art to determine the relative position of points on, above or beneath the surface of the earth with respect to each other by measurement of horizontal and vertical distance, angles and direction. Little bit simple compared to the Punmaya. Here I try to conclude that surveying may be defined as the art, since we should know the imagination how to do, and it should be logical. So art and science of determining the relative position in 3 dimensions of natural and man-made features on or beneath the surface of the earth by measurement of horizontal and vertical angles, vertical distance, angles and direction. These features may then be represented in analog form as a contour map, plan or chart, or in digital form as a three-dimensional mathematical model stored in the computer. Right? So based on this, you can now try to define what is surveying. Right? So art of determining the relative position, or art and science of determining the relative position. Right? That is the definition of surveying. So now we have understood the importance of surveying. Next is the objectives of surveying that we are going to discuss. The one thing is the end product of surveying. I need to draw a plan or a map. Right? These are the main two objectives of survey. What is plan? What is map? What is the difference between them? When the area is surveyed is small area and the scale to which its result plotted is large, then it is known as plan. Say for example 1:100 or 1:200 or 1:500. Generally our house plan is called large scale map, that is called the plan. If the scale is large and the area is small, it is called plan. To the contrast of it, map, when the area surveyed is large, say example the entire district or entire state or entire country. If the area is large and the scale to which its result plotted is small, then it is known as map. Say India map, Tamil Nadu map, a particular district map, my house, in which is we can call as plan, which we can call as map. All the India map, Tamil Nadu is map, district is also map, but my house is drawing is called the plan. Since the area is very small but the scale detailing is high, but in the contrast, the map scale is very small but area covered is very high. That is the contrast. So 1:10,000, 1:1 lakh or 1:20 lakh, whatever, if that scale is maintained, it is map. Right? So the objective of surveying is to draw map and plan. That is the end product of it. It may be done by computerized or by manual. Next specific outcome is the principles of surveying. The main principle of surveying is working from whole to part and to localize the errors and to control the accumulation of error. We need to avoid the accumulation of error, and the error, if happen, it should be localized, it should not be a globalized. For that, the main principle is working from whole to part. How we can achieve that is establish primary control points with high precision, establish secondary and tertiary control points within the system boundary, and form triangle or rectangle maybe with less precision. This will help in localizing the error and to control the propagation of error. Say, let's consider a particular piece of land. It has, we don't know the shape. If you join the outer boundary of that land and we can measure the distance between point to point, the red marks are called the major control point and the distance can be measured. If this should be done very precisely without any mistake. Now we need to get the area of it. How we can get the area of it? So now we can split the area into triangle or rectangle, whatever the mathematical shape. Predominantly we can use triangle is the best way. Why triangle is the best way? It is the least number of side we can have, and if we are able to get the three-sided distance, we can get the area of the triangle. Similarly, if you sum all the area of triangle properly, then it will give the total area. But it may be less precise, but the error can be localized, right? So we can avoid the accumulation of total error, and the error will be within the small limit. That is the major principle of surveying, working from whole to part, not from part to. If you split all the areas into bits, then you will try to find the boundary means, you will end up with more accumulation of error. There won't be any control. So that is the major thing, working from whole to part. So a hierarchy of network of control point will be established. You can check with the next picture. It requires most skilled manpower and costly resource, which are rare and cost intensive. Precise instrument has to be used, so that only we can collect the proper data and proper analysis can be made. Suppose a huge area we need to survey and we have to fix it. All the black dots are called the control point. With respect to that, then we have to fix the intermediate point or tertiary point, and then we have to set or calculate the area of the required part of the land, right? So this is the most important thing should be followed while doing the surveying. So the purpose of working from whole to part is to localize the error, again I am repeating, and to control the accumulation of error. Apart from that, how I can fix the distance, how I can fix the point, everything, there are many mathematical logics. If you know two standard points and we need to fix the third point, and you know the distance between that point with respect to the two object, then it is like making an arc from the 2 point. The meeting point gives the third position. Here the two distance L1 and L2 if known, this can be and we can avoid the error also. So at least two independent new distance is required to fix the new point. If not, there are 2 points with known distance, and I know the x is perpendicular to this line, and from either from z or from y, if I know the distance and it meets at that point O and it should perpendicular, means I can easily fix the x point. Since it is perpendicular, I can draw a straight line with the known distance. If that r cuts the known distance, that point gives the third position, so through which I can fix the third point. Similarly, I can extend to many things. If not, I not confirm based on whether it is perpendicular or not. If I know one distance and one angle, in that also I can try to able to fix the third point. I know there is a known distance, I can cut that and I know the angle between these two known points. So with respect to that angle, I can draw this line and I can cut the point. So I will get the x point. If I join to this, I will get a triangle. Similarly here, right? And the last one, I don't know the distance between any point, but I know the points. Yes, z and y is there, I need to fix the x, but I know these two angles. If I mark those angle with respect to proper instruments which can give me the angle, or which I can set the angle, I can easily, if these two lines will meet at a common point, that will give the third point. The point of intersection of two measured parameters defines the position of the new point. So these are the ways we have to adapt while doing the surveying, working from whole to part, to establish the control point and the shape of the plot to determine the area or any distance. Next comes to the types of surveying. There are two types of surveying: plain surveying and geodetic surveying. These are the major types of surveying. We will see one by one. First one, the plain surveying. Here the earth surface is assumed as a plane and the curvature of the earth is ignored. That means the earth is flat. So the plain surveying extends only over small area. Our building, our house building, it is considered as a plot. But our district means our plot is a part of it, and the district has a major ups and downs, everything. So there we can't ignore the curvature. But my plot, I can consider it is a flat. I can level it, right? So as the plain surveying extends only small area, the line connecting two points is considered as a straight line, not the spherical line. And the angle between those two lines is considered as plane angle, right? So here the curvature of the earth is ignored. So then contrast to it, in geodetic surveying, the surface of the earth is not plane, it is considered as a spheroidal. The curvature of the earth is considered. Therefore the line connecting any two points on the earth surface is not a straight line, but it is a curve. So the angle formed between those curves is called the spherical angle. The surveying in which curvature of the earth is taken into account for all measurement is known as the geodetic surveying. Here the surveying should have a high degree of accuracy. If you make a small mistake, it will get more accumulated. So predominantly trigonometrical survey is followed. What it is trigonometrical, we will see it later, right? So the contrast between the plane surveying and geodetic surveying, the earth is considered as a flat in plane surveying. Here the earth is considered as a spheroidal. The curvature part is taken into account. There it joining the 2 point straight line, here it is a curve. The angle formed between the two lines, there it is plane angle, here it is a spherical angle. Less than 250 square kilometer, if the surveying is made, it is plane surveying, and if it is more than that, then the surveying is geodetic surveying. The accuracy also required. So this surveying is mostly adopted in the country wise or at least state wise, right? Geodetic surveying. Next comes to the classify the surveying based on different categories, right? So we will continue this in next class.